Hi, this video is about the summarizing a second activity of a motion with a continuous force. S1. If a card is at rest and a single force acts on it, what happens? If the same force continues to act on the card, what happens to the card's speed? Um, if it's the card is in the rest and a force acts on it, the speed of the cards increasing. If the same force continues to act on the car's motions is at the same speed that receives from the force. In general, S2, in general, during this time, a single force with a constant strain acts on the moving objects in the same direction at its motion. What is the object's motion like? Does it move at a constant speed? Does its speed continuously increase, or does the speed only increase at first and then become constant after a short time? What evidence from this activity supports your thinking? When a single force acts on a moving objects with a constant strength in the same direction at its motions, it causes that the moving objects um, move at a constant strength, and activities that we do in this chapter 2 supports my answer. S3, when you were using your finger to try to push the card with a constant strength force, you probably noticed the card was getting away from you. Why do you think the card behavior in this way? When we push when we push the card with our hands or finger and to forward, our hand give the force to the card and go forward and get away from us. For S4, suppose that while the cart was being pushed along the track by the fan unit, one of the fan blades jumped so that the fan unit immediately stopped pushing on the cart. Based on your collect evidence, what do you think would happen to the speed of the cart? Explain your reasoning. Um, when the fan turn on and works, the cart speed up and moves. But when the fan immediately stops pushing on the cart, the motions of the cart decreases and stops. For the S5, at the beginning of the unit 1 of this unit, you scaled a speed time graph for a soccer ball that was given a quick kick and then slowed to a stop as it rolled across the grass. And it asks us to draw this graph for the two sections that ask us. First section of the graph during which there was a contact push-pull interaction between the foot and the ball. A is my first graph that is in contact push-pull interaction. When the foot and the ball is interaction with each other, the foot gives its energy to the ball and ball moves, and when they lost the interaction, moves for a while and stops. For the second part is the graph for during which a force acts on the ball in the same direction as its motion. The forces for on the moving objects that is in the same direction. When the forces acts on the ball is moves, and when the forces there is not force anything there, the ball is stops moving. For the S6, I agree with the Han that when the fan is keeping pushing on the car, yes, the cart is keep speed out, and when there is a force there, the cart is moves and keeps speeding, and when there was not force there, the cart's motions decrease and stops.